This is Autoline After Hours with John McElroy and Gary Vasilash, episode 568 for August 26th of 2021. Battery fires could kill the EV revolution. Watch Autoline After Hours live at Autoline.tv every Thursday at 3 p.m. Eastern Time. That's 12 p.m. Pacific. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or YouTube.
Autoline After Hours is brought to you by Bridgestone Tires, solutions for your journey, and by Magna.
Gary V, what up?
Not much. How you doing, John?
Doing pretty good. Just got back from, literally just minutes ago, got back from driving the new Hyundai Santa Cruz pickup.
Which I drove yesterday.
Oh, good. So we'll talk about it later in the show then.
That would be an idea. So yeah, I'm very happy. I have electricity. I have air conditioning. It's brutal out there, as you well know, having just come in.
It's hot and humid.
Now, you and I have probably been to more press introductions of vehicles than either of us would want to admit. And over the years, we've seen some rather extreme ones, the Grand Cherokee busting through the glass at Cobo Center, or the Cattle Drive, or acrobats that are flying around cars, or skateboarders or whatnot. Okay. But on August 26, 1957, there was a press introduction at the Ford Dearborn Proving Ground, which included stunt drivers that were taking this vehicle that was going to be introduced and putting it on two tires. They had a towing demonstration where there were 4 tractors being towed, which allegedly was 200,000 pounds with this vehicle. And so my question to you is, what vehicle was it that was introduced to the press on August 26th, 1957?
I'm going to guess the Edsel.
Bingo, you are correct.
Finally, I got one right after months and months of missing them.
Nah. But I mean, what a bizarre thing. I mean, who would have thought that this was going to be a vehicle that would, go through, towing, that much? I mean, did people tow a whole lot back in the 50s?
No, not with their cars, certainly. But as you know, it's a press intro, right? So if you had cars parked out there, ho-hum from a photography standpoint. But if they're up on 2 wheels, if they're hauling a massive load and doing all kinds of crazy things, pictures like that get picked up by the photographic wire services and broadcast all over the country.
And then I guess all I can say to that is, how'd that work out for Edsel?
Hey, we're still talking about it.
That's true. But, yeah, not with an entirely positive approach. But yeah. Okay, that was then. This is now.
Yes. So let's go ahead.
So I was going to say, let's bring in our journalistic colleague, Bengt Halvorson.
Hi guys.
Car reports.
Hey.
How are you?
Bengt.
Doing well. It's I look at all the news flowing through, and I cover green vehicles and efficiency and the shift to EVs on a daily basis, and no week is boring. There used to be a summer slowdown in the auto industry, but we're just busy all the time.
Yeah.
So Bengt, you're actually on the other side of the country from us in Portland, Oregon. Is that correct?
That's right. I'm in Portland, Oregon. You guys are talking about hot weather in Michigan. We've had 3 100-degree heat waves this summer, and yeah, I know the feeling. It's Portland has been a good place to watch this EV shift, because it's, in Portland, we've embraced electric vehicle charging for years. I mean, we just passed the 10th anniversary of the West Coast Electric Highway, so they're literally putting in second generation fast chargers in this network, and so we're at a different place than the rest of the country. There are probably some lessons to learn, but also it's, in some respects, I'm saying, hey, it's about time.
Well, we'll get into that more too.
Yeah.
Gary, why don't you introduce our special guest today?
Oh, John, I'll let you handle that.
Okay. So Jason Lisseman is from Joyson Safety Systems. And Jason, great to have you on Autoline After Hours with
well,
us.
thanks very much for having me, guys. It's what a privilege. Thank you.
So Jason, you're the guy who is with Integrated Safety Systems. What does that mean?
Oh, that's a loaded question. We have a lot of new technologies. So we're playing with a lot of new technologies or in the safety domain space for a lot of different segments. So we have a vision and radar group, we have an event protection group, we have a steering systems group, we have a sensors group, we even have a premium trim and personal protective equipment group. And so we have quite a wide array of technologies, a lot of mental gymnastics involved to jump from one subject to another, but it's very exciting and it's a lot of fun.
So where are we going with safety systems? I mean, every time we go to a new car introduction, they have pages and pages of new technology systems, automated braking, blind spot detection, lane keeping, rear cross traffic alerts. I mean, the list just goes on and on. Is there more in the pipeline, Jason?
No, absolutely. The problem is us, humans, we're flawed. And as a result, eventually we're going to get replaced with a robot that can do it far better than us. The issue is up until that point, there's a lot of lessons to be learned. Mm-hmm. So yeah, we taking the point that Bengt had raised earlier about electric vehicles, a little known technology that we've just pivoted with is a little pyrotechnic battery disconnect device that sits in the battery management system that in the event of an accident, we sever all power to all vehicle systems. And that keeps our first responders and our occupants safe from electrification. Because in the event of an accident, you have to make sure that 450 or 500 volts or even up to 1,000 volts and 20,000 amps doesn't short to the body in white and electrocute people.
Yeah.
Okay, so how does this work? So basically, it detects the collision and then it cuts the wires?
No, so it's an active system. So the vehicle crash system knows about the accident. But there's also other sensors within the battery management system, looks for the temperature of the battery and other such things. So from a signal, when the OEM makes a determination that this is a risk or it's a particular threshold of an accident, they can fire this device and we effectively break the copper bus bar that passes the electricity from the battery system to all of the vehicle systems in under just over 1 millisecond. And in doing so, we generate a huge plasma arc that we have to manage and mitigate. And the higher the voltage, the higher the amperage, the more challenging that gets. But,
no kidding, man. I mean, a pyrotechnic device on top of a battery just doesn't sound safe.
It's such a small charge that we're effectively just using a pressure wave to effectively move this piston to break it. It's a very tiny device. I mean, the good thing is we have the smallest one on the market. And what's interesting is we see a huge amount of interest from the market because I guess as Bengt realized that this market shift, it's massive. And as there's more and more of these vehicles on the market, there are going to be more and more issues that they see that they couldn't foretell. And this gives them a level of control. So we introduced the very first one in 2017, and we've just implemented a second generation just recently with Volkswagen. And the industries, we've got a huge amount of interest for it.
Now, Jason, this technology primarily deals in this generation still with the safety of first responders and occupants in not getting electrified, right? But in the future, this technology could potentially be harnessed. I mean, what you're dealing with essentially is a giant short, and you want to not necessarily stop that short in the battery or that thermal runaway, but you want to control it. And so this could be one of several devices in the future that could be used to control thermal runaway. Am I right?
And absolutely. So, for example, if you've got a read from your charging system, again, we all know from consumer electronics how many random charges people use and batteries catch on fire. This is going to be an issue that faces the vehicle electrification of the vehicles. It's a similar issue, as people don't want to buy a regulated charger; they want to buy their own from Amazon and install it themselves, for example. And so as long as you've got the smarts getting the read from the battery, the battery system's got the ability to say, "Oh, it's too much. I'm going to shut the battery off."
Mm-hmm. Joyson,
and sorry.
No, go ahead. Finish your thought.
No, I was just going to say that we talk about first responders and electrification of occupants and protecting them, but there's also, from an insurance perspective, saving the most expensive parts of the vehicle by preventing from frying them is a huge part of this as well, keeping the repair costs to a minimum.
That's amazing. So could this prevent the kind of battery fires like, we've just seen on the Chevy Bolt, or no?
I can't speak specifically to the Chevy Volt scenarios, but I know that we've installed this on a number of Teslas in a number of regions, and we haven't seen the same level of fires from the devices that are, where these devices have been fitted, because it gives the OEM a control factor. I mean, thermal runaway events, you can put a level of control in, but once that thermal runaway event happens, stopping it is going to be nigh on impossible.
Yeah, is this something Joyson did on its own, or are you selling these things to Tesla?
Yeah, so the very first one we introduced with Tesla in 2017, and then we iterated our own smaller, more compact version, and we introduced that with Volkswagen, and again, huge amount of interest with it. It's a device that people don't recognize is out there, and it's when we start getting the word out about these devices, it's spurring a huge amount of interest.
Jason, you mentioned to move away from electric vehicles, how robots will be driving cars. Now you guys are heavily involved in moving us toward higher levels of autonomy, specifically by doing occupant analysis systems, as it were. You guys are on Super Cruise.
That's correct.
So explain to the audience, what these devices are and why they are important.
So the first one to talk about is principally the driver monitoring system. So as you all know, distraction is a huge problem for the industry. So again, by nature, we're flawed. And in driving, we all like to think that we can drive at faster and faster speeds and handle corners and so on, but the reason the fatalities exist is because we are flawed. So the distraction system, the driver monitoring system, is effectively looking at the driver's facial features and picking out indicators. So we're looking for head pose, we're looking for how open the eyes are, we're looking for micro sleeps, we're looking exactly where the driver's looking. So for example, if the vehicle could spot a pedestrian is walking in front of them, then and they are not looking at that, they're looking at a cell phone, or they're distracted looking at another display, then the vehicle can warn the driver appropriately that they haven't seen it. And in many ways, when we implemented this with General Motors, it was about almost like a training aid that was saying, you can use this automation, but you're still responsible and you still have to be able to take over. And really, you're training the user that says you can engage it, but it doesn't devolve you of all of your responsibilities. So now, as we beyond that, then looking for distraction all the time while you're driving is kind of a big deal. So naturally, if you expand from the driver monitoring and you say, okay, well, what else? If you think about when we all took our driving test, the driving instructor tells you, keep your eyes on the road and hands on the wheel. And that's another technology that we pioneered with General Motors, was a multi-zone hand sensing system. So we can tell when your hands are on the wheel. And then we put the light bar on there to tell the driver when, as another visual indicator. And those three themselves kind of play off each other. But if you take a look with a broader sense and you look at automated vehicles, looking after the driver's one thing, but what happens if there's no driver? Now you have to look after the occupants, because, again, we do some crazy things in cars. We've all seen those images of students packing 27 people in a car. So, you have to look for that, because we've got to protect them, because there won't be a captain in the car seat telling them, hey, don't do that. So we've got to replace that with some monitoring systems to be able to check. And then, unfortunately, extending just to kind of a regular point of, the unfortunate instances where we see 50 or so infant deaths of children being left behind in vehicles, which is a tragedy. And looking for systems that can protect that, which then gives you the ability to start to fuse that data together in a smart way that you could apply different mentalities and different approaches to the safety system. This is a part of a journey. It's a journey we're on. And eventually, we will be replaced with robots driving cars. It may not happen tomorrow, it may not happen in 10 years, but it's going to happen in, within that 30 to 40 year window. It's going to happen.
Joyson, processing of automated driving and processing of all of these inputs from vehicle systems, it's going to get centralized eventually. We hear automakers moving processing down to essentially two very impressive computers, in the near future. Ultimately, though, what this amounts to is a lot of sensors in the car. There's no consolidation of the sensors. And so could you give us an idea of, when we look at the self-driving vehicle of a few years from now, or the just electric vehicles, let's take as an example, how many sensors are going to be aboard these vehicles in total? And then as a supplier, how many of those do you hope to be involved with?
That's a very open-ended question, but let's think. So just think about some of the sensors we have today. So the regulations in North America, FMVSS 208, require we have the ability to turn off for a rear-facing infant seat. So that OCS system is going to stay around for a while, until the visual domain systems, such as a 3D camera, can to do the depth perception analysis of it. So camera systems, that they're going to proliferate. Direct contact sensors are always very, very valuable, especially as you go through the functional safety aspects and you go up in terms of the ISO rating. You need a level of redundancy in those sensors, so that you can absolutely be sure that you're making the right decision. And then obviously, the things that you see, that's one. The things that you hear, there's another. The things that you smell, that's another. So as daft as it seems, gas sensing and smelling the inside of a cabin of a vehicle and smelling for chemicals that shouldn't be there. For example, smelling for toxic gases from a battery electric vehicle, for example, is an area that could occur. But again, smelling the inside of the vehicle, the last thing you want to do is call your automated Uber and then it smell like rotten fish. So on the other side of the equation, it's going to be a while before we get there. So in the interim, we're going to have kind of more of the driver supplementary sensors, the hand sensing. The alcohol sensing is going to be the next, one of the next big waves if it passes through the house, and that's another big point. And then this is just talking about the inside of the vehicle. Radars, that's something that we're working on. Temperature sensing and the likes. The more information, the more senses you can give an intelligent system, the more informed its decision making is going to be. So
for sure. And yet Tesla is saying it wants to just go to a vision system, a camera system. I understand what they're trying to do. If they don't need LiDAR or radar, sure, why not? But as you say, all those different sensors capture different kinds of data. And yeah. I would think that other automakers are probably not going to follow the way that Tesla is going, including the fact that radar and LiDAR prices keep coming down.
That's very true. I think, again, if you think about a human, we have our three primary senses. We've got other aspects that we can rely on, and you make your decision based off what you see, what you hear, and what you smell, and what you touch, and what you feel, etc. So the more senses you can give to an intelligent system, the more informed its decision making is going to be, and that's really, really the challenge. Is just relying on vision is one aspect, and you can do a pretty good job. You can do a great job, but can you do depth sensing? Can you do depth sensing? So then you add the depth sensing aspect to it. Now, does that cover every scenario? What about if the camera gets blinded from direct low sun, for example? We've all had a situation, you wear sunglasses because you don't like the sun in your eyes. So what happens to the camera system? And there's only so much, so much optic work you can do before you're just trying to beat the laws of physics.
Joyson, now I've got to ask you, I mean, this gas sensing system. So, I read about it that, you guys claim you detect, classify, and quantify VOCs in the vehicle cabin using multispectral sensor system. Okay. So you got to tell me about that.
Yeah, translate that.
Yeah.
In simple ways, we're trying to build a digital nose. That's what it is. So realistically, you're trying to smell for certain chemicals and certain things. I mean, in our research team, you'll see bags of gases that we test with, and you pick one up and you go, oh, sweaty socks. Oh, how do you calibrate the smell of a sweaty sock? But that's the thing that some of the customers have expressed interest in. And again, as you start to move forward with these automated vehicles, these are the things that there isn't somebody there to tell you, hey, there's a smell.
Yeah, but I think what Gary's getting at is,
and these vehicles, they want to get maximum usage out of them.
Yeah, you're doing spectral analysis, right? And so you're beaming a light through this gas and interpreting the light to translate that into what kind of smell there is.
That's right. That's exactly right. And a similar approach we use for alcohol detection systems, so we can detect alcohol in your bloodstream.
And the physics of this would be a bit different than the fine particulate matter sensors that are starting to get into some vehicles, right? Is that also a business line that you're pursuing, like something that you see? Okay.
No, so we always look at where what the problem. So when we develop a technology, the first thing we always get our heads together and go, well, what problem are we trying to solve? It's not about pushing a technology for technology's sake. There's got to be a reason behind it. So driver monitoring system was born for a specific set of reasons. Pedestrian hood lifters projects, they were driven for a particular set of needs. And so the reason here was, what can we tell about the interior of the vehicle, that the air that you breathe, these automated vehicles, when there is no captain, then OEMs are going to want to care about the smell of it. But at the same time is that there are people with nefarious, desires that will do things with automated vehicles that we need to be ready to be able to protect people for. And that's how some of these technologies start out, as an idea to solve a problem that we see in the world. And that's pretty much what drives us forward. And that's what keeps us excited on the technology front.
Hey, I'd like to go back to that pyrotechnic switch on EV batteries. Can this prevent EV battery fires?
Potentially. If the sensing system can detect the beginnings of a thermal runaway event, then the question, if the battery's damaged, if you've run over, you hit a big pothole, as we all know exists in Michigan, so you hit a pothole, and the battery gets damaged, and then you have a thermal runaway event 5 years from now because the cell's damaged and it's degraded over time, then the ability for us to stop a thermal runaway event is a challenge. But if we know that the vehicle is going through an accident, if we know that there is an overcharging scenario, that's where we could try to at least prevent the damage to other systems. I mean, there are things we're looking at in other areas, which I can't obviously go into too much detail about ways that we could try to mitigate fires and thermal runaway events using some unique chemistry and materials and solutions.
I mean, potentially you could put versions of those pyrotechnic devices at each at the module level, right? Between banks of cells, and achieve an even more accurate or fast cutoff, right?
Yeah, it all depends. We've got a lot of conversations going with battery suppliers, tier twos, and we're in detailed conversation with many of them about how these systems could work. And again, we don't make the battery management systems. We're looking after a particular aspect. So it's only with the deep collaboration that you can start to open up some of those additional opportunities.
So explain this to me. I mean, whether it's this thing for the battery or anything else you guys are involved with, so there's a sensor involved, there's a processor involved, and in some cases there's an actuator involved. So what does Joyson provide to the OEM for these three areas?
So we start with the actuators. That's kind of, if you think about an airbag, it's pretty much an actuator system that's handled by my colleagues in a different division. But if you think about into the ISS group, we have hood lifters. These are actuators. These are small charges where we lift the hood a given distance. So
this is somebody gets hit by the vehicle, the hood moves back.
So we pivot the hood at the base of the windshield. So we lift the hood at the base of the windshield. So effectively increasing the wraparound distance. So we're effectively using the hood as an energy absorbing surface. So we lift it, we manage the energy, and therefore we prevent injuries from the head striking the base of the windshield. We put four on. We introduced with Polestar a new system, which was for cyclist protection, where we actually lifted and articulated the hood so we could increase that distance even further. So actuators, those are things that we, from a seatbelt group and airbag group, and obviously on this and the event protection team that we have. And then we have the pyrotechnic battery disconnect, which is an actuator device. We're not in the sensing system of the battery management system, which things that are areas that we're looking at. We're not today in the pedestrian sensing system. That's an areas again that we're investigating and looking at. But again, we're looking saying where can we add a value to the market? Where can we add a value? Where can we be different? If you take a look at the sensors, we do a lot of sensors from the occupant classification system, our new integrated foam sensor system, from hand sensing on the steering wheel to the camera systems, to the radar, to the thermal imaging, to the 3D time of flight cameras. These are areas that Joyson is very much involved with. Does that help, Gary?
Yeah. So okay. So you have these capabilities, but are signals sent to you and then it said, okay, cut this off, or are you doing the processing that says, there's a problem here, make the actuator work?
So the vehicle's making some of the decisions. So we've got, obviously the vehicle has got crash sensors around it. It's got speed, yaw, rate sensors, etc. So we can determine the severity of an accident, and that allows the OEM to make that decision of when. There are many other sensory information that they can use from the vehicle OEM perspective to enable them to make the smartest decision. So we're not in that decision-making process. We're providing that information in the best way possible for the OEMs to make the best decision for the occupants in the vehicle.
Mm-hmm.
Jason, could we talk big picture future for a little bit in terms of autonomy? When we look at the past several years, the auto industry has been sending out a bewildering array of signals about when self-driving is arriving, when these autonomous levels are arriving later in the decade. There was a lot of hype in 2016 to 2018 especially. How, as a supplier, are you dealing with all these conflicting signals and the changing timeline? And like generally or specifically, where do you spend your development money accordingly? What assumptions are you making for later this decade?
So we're a business. So again, our job is to save lives, and that's an important part. So we in the market, in our history, especially in my team, we've developed some technologies that were ahead of its time, and you spend money on it and then you bookshelf it, and then you decide that the market goes a different way. So that's obviously money that you try to avoid spending so you can spend it the most effective way possible. So we always try to do some analysis of what the problem is, what the opportunity is, and what's the real impact at a real world level to people and society when we put these technologies out there. So we're very pragmatic with it. So when we introduced the first driver monitoring system, we had a partner in GM that shared that vision of what we were trying to do. to enable a safer deployment of autonomous systems. Again, from that perspective, then it's about the iteration of that technology, the evolution of that, adding new features, making it more robust, making it cheaper, adding more advanced features, and then it's an evolution of that system. And then the natural evolution is, okay, if I can do that for the driver's side, I can start doing that for the passenger side, and so on. So what we tend to do with our OEM for colleagues is we present them opportunities of technologies and have detailed conversations. Now, does this fit your vision? And we use these technical forums to get their feedback. And that tends to steer us then at a working level, because again, OEMs, they have a market. They want to show that they're the cutting edge to sell vehicles, and but then at the working level, when they deploy a vehicle or they're planning a new vehicle, sometimes there's a different angle to that or a different approach. So we try to work closely with OEMs to make sure that the solutions we're offering are what the market really wants, what that OEM wants. And some have great vision, they're aligned with us perfectly, and so others don't. And that's like so that's okay, because there's not one right answer in this world right now.
Do some of these ideas that you're working on, perhaps, when you get to advanced levels of autonomy, include, the mind-boggling physics of the presentation of the steering wheel, perhaps, and this sort of transition area?
So, hopefully, I mean, there's going to be one day that the steering wheel will disappear. But if you look at the number of vehicles on the market, we talk about automation, you have to look at the tipping point. At what point do we get 50% of the market that are autonomous? And that's a long, long, long way away. A long way, because people are not going to want to pay for it. Some people want the functionality, but they want to also have the confidence that it's going to do exactly what they want them to, want it to do. So the wheels can...
But the vehicle will pay for itself, right? It'll be worth 3 times as much.
Well, there's an I remember reading an article about a university in, I think it was Australia, and they said, when you've got an automated vehicle, think about all the fun things you could do. You could have this car do all of these things. So they paid They paid a taxi driver to effectively do what the owner wanted, and they thought that the vehicle miles traveled would actually drop, and it actually increased, and actually made congestion worse. Yeah, so
I think we're
all right.
going
So let me ask you something that's more granular, more today, less futuristic. Now, oddly enough, you guys have developed different, like you call them 3D switches. So yes. I mean, so basically, for instead of, as we can see here on the screen, so someone touches those surfaces and seems to press it. Does anything, like, is it all haptic? Is it all feeling in the person's thumb or finger? What's going on there?
So it started life as a force sensor. This is principally what it is. It's, for us, is a primary sensing technology that we're investigating use elsewhere in the vehicle. And for us, the natural extension of this was deployed to a human machine interface, because you get in vehicles today and you'll see a majority of black painted laser etched mechanical buttons, and people ask, well, why aren't they kind of more consumer-esque? And so we said about, okay, well, what would be the advantage and disadvantage? What would be a good solution, a bad solution? And we struck upon the idea of pure force sensing. So we use force not just to detect an amount of pressure or force applied on a surface, but we also track the location of said force. And then you want to make sure that you get some sensation. So we use acoustics to generate a sound of a button, and we use the acoustics to generate the tactile sensation. And the way in which we do that, we fool your brain into thinking it's happening exactly at the same time. So you have a smooth surface, you're touching on this smooth surface, but it feels like a dome cap, moving, crushing, collapsing.
So Jason, these will activate even without you touching it? You just get in within a given proximity?
No, so we can do that, but a lot of conversation in the HMI domains is about, you could do hidden till there, then you bring your hand in close and it lights up. But the one thing about user-centered design is people want to know where buttons are before you start waving your hands around to find it. Last thing you want to do is accidentally activate the wrong thing. So for us, we use force as a measure of intent. And we can set that level to 3 newtons, 4 newtons, 2 newtons, half a newton, whatever it is. So it enables you to wipe the surface without activating a bunch of controls. And you can wear gloves because, again, we live in Michigan and a large portion of the world live in cold climates. And we don't want to be going buying special gloves or asking customers to go and buy, hey, go buy a special set of gloves so you can use your capacitive controls. And this is where it was born. But it has other benefits for us as a sensing company, as a safety company, about how else we can use this technology in other areas of the vehicle. So this was a start. And one of the newer technologies that we're working on is now iterating that even further and putting that behind seamless panels. So we have a fantastic demonstration where we've turned a piece of pure carbon fiber into a bank of buttons. And that's hard to... It's hard to get across to people when you touch this thing and it feels like a button, but nothing's moving. It looks like a button, kind of think it's a button, and it's seeing is believing. Touching and feeling is a big part of that.
So when you say that you're using acoustics, you're using literally sound waves to press back against your finger to make it feel like you actually pushed a button down.
Yeah, that's right. We're effectively it's imagine it being a low frequency speaker. It's like when you're sitting in a chair watching a movie and you feel the rumble of a bass speaker. We've just honed in on that for a very specific aspect of it, that for touch. And we can change that sensation and make it feel like a million and one different things. We can change the force level, and we've got some really cool functions that the harder you push, faster things happen. Because again, we always use the alarm clock analogy when you're trying to set your alarm clock and you push and hold and you go faster, and after several seconds it goes too fast and you overshoot. And and then you get frustrated. We're like, wouldn't it be cool if you just want this to happen faster by pushing harder? Because that's human instinct. When you're in an elevator and you want when the doors to close, you kind of jab at the button harder and harder till it closes. You're not changing anything, but you feel good about it.
So the piece of carbon fiber, it never moves.
That's right.
But when someone touches it,
yep,
they have a sensation that it's moved.
That's right. We set the threshold. We set an activation threshold and a release threshold. So we give you the click on activation, and then we give you a release click on deactivation. And that's the key thing. I mean, my team and I, we worked a ridiculous number of months perfecting the off click. Most people wouldn't even think about it. But for us, it was about completing the experience and making it believable and paying homage to the way we like systems to operate, and a number of research studies and clinics, etc., to get this experience nailed down the right way. So
the making it believable thing, I think, here is key, because at one of those aspects that can drive drivers crazy is latency.
Yes.
And so as a safety company, you understand that timing is everything. So getting that timing, perhaps more than every other sensation correct, is probably
that's right. There's a holy grail of 125 milliseconds to a response from a touch that you have to try and achieve. We got ours down to 35 milliseconds.
Oh, that's impressive.
So,
hey,
again, the team that I work with are phenomenal, a fantastic, smart bunch of people that I'm incredibly proud of to pull some of these technologies and making them real.
Yeah, look, we're going to have to wrap this segment up, but thanks so much for coming on, Joyson. This has been fascinating. I had no idea Joyson was into so many different things.
Well, thank you very much for having me. Again, it was an honor and a privilege. And again, thank you very, very much.
That's
Thanks,
great.
Jason.
Thank you.
We're going to take a quick commercial break. We're going to come back and talk about a whole lot more things going on in the automotive industry. All right, we're back. That was a great segment. I didn't know that they were working on any of that stuff. And the reason I asked about non-contact is I actually have played around with a different supplier working on a system with non-contact. You know, your finger doesn't touch anything, but it feels like it touched something. But I like his idea that you don't want to be waving your hands around and setting off other controls.
Well, I've got to confess that I'm a sensor geek. You know, anyone who played around with those old Tandy electronic sets as a kid will understand that you know, you get a sensor in the mix, and there's so many just amazing things you can do. So yeah, sensors are cool.
Yeah. So, Gary, you got some things for us to get into, and I know at least one of them ties in with the conversation we just had.
So I thought it was interesting to note, and this is you know, again, Bengt on your side of the planet. So Monday night, an Alaska Air flight from New Orleans landed in Seattle. Now I know you don't live in Seattle, but it's close. And the plane was at the gate, and a guy's Samsung phone burst on fire, and there were 129 passengers, 6 crew members, and they actually had to take the slides to get off the airplane. So fortunately, he was at the gate. Nobody was injured.
Wow.
Which then leads me to the whole issue that we were talking about. That so General Motors has now recalled all of the Bolt EVs and Bolt EUVs that it has produced because of the potential that there could be a problem with the battery, which could conceivably lead to a problem. But you know, so I was thinking, wow, you know, there's still cell phones that are getting on fire. So here's my question to you guys. Okay, A, what are the implications that this Bolt situation has for General Motors? Because as it moves forward, it is going more and more toward electric vehicles. And B, what are the implications for just the whole EV segment of the business, that people who need to be convinced, oh, maybe I ought to look at an EV, might be saying, maybe I better not be looking at an EV because I really don't want to have a fire as a result of one of these. Yeah. Is this a big implication?
Well, I think first off, we need to look at this situation in particular, and smartphones, they don't use quite the same type of battery, but also they don't have firmware and software that are constantly monitoring the battery condition in the same way as an electric car might. And they don't have cooling or liquid cooling systems as an electric car might. And, you know, back to the cell types aren't designed to last many years in the same way that electric cars are. So there are a lot of distinctions, but at the same time, this is really worrisome, especially with the recall last week. You know, I think GM expanded it to 110,000 cars in the US and 140,000 if you include Canada. It's a lot of cars. And last I checked, they're planning to replace all the modules of the battery packs in all of those cars. I think that before we dive into this particular situation with the Bolt a bit more, that we need a sort of, we need to take a step back and look at how battery fires, you know, taking a deep breath, electric car battery fires don't happen as often as fires do for gasoline engine vehicles. They happen, you know, the statistics show that normalized per mile traveled, per all sorts of other common safety statistic. In other safety statistical terms, fires in battery electric vehicles just don't happen as often. And so then we need to ask, well, why do we hear about fires in battery electric vehicles so much more often then? And the key to this is that, well, one of them is that fires in battery electric vehicles are long. Their duration is often hours. They sit there and smolder on the side of the road or in someone's driveway. People from the neighborhood come and look at the vehicle smoldering and how much trouble the fire truck is putting out the fire. And that leads to the second issue, which is emergency personnel don't really, there's not enough education out there on how to put out electric vehicle fires. So, I think some of it has to do with education and just understanding that electric vehicle fires are different. At the same time, you guys, how do we convince consumers that this is just a bump in the road and this isn't a really serious deal breaker?
Look, I think this is a really serious problem for the automotive industry. And I agree with everything that you just said, Bengt. There's over 100 car fires a day with ICE vehicles. They never make the news whatsoever. But one battery electric catches fire and it's headlines around the world. That's just a reality. That's going to happen. And it is scaring people and making them second guess whether they really want an electric right now. And to show you how serious it is, I mean, General Motors is throwing LG Chem under the bus. I don't know if you guys saw the statement that they put out yesterday, but it's like, we're only going to use LG batteries once I'm paraphrasing. I don't have the statement right in front of me, but, essentially what they're saying is until LG Chem gets its quality act together, we're not going forward. And mind you, they're already committed to building 2 battery plants with LG right now today. And they've hinted at two more to come. Exactly. And it sounds to me like they're going to hand LG Chem the bill for this recall, which has now jumped from $1 billion to $1.8 billion. And man, I would not want to be in LG Chem's shoes right now. But what I'm getting at is it shows how serious it is that GM is doing everything it can to blame its supplier so people don't think it's at fault. And we haven't seen an automaker attack a supplier like this since Ford went after Firestone.
Hyundai had what sounds like a very similar issue with the Kona Electric earlier this year. And they mentioned LG once, that they were seeking reimbursement from LG. But, and this may have been covered in greater depth by the Korean press, but from what we saw of that situation, it very quietly got settled with LG, and Hyundai just went ahead and is replacing all of those batteries. You're right, that Friday 5 p.m. press release about the expanded recall of the Bolt last week, they included a line that they were seeking reimbursement from LG, and then more comments later. It is very jarring for the industry, especially given LG's mutual interest here. And this joint venture, Ultium Cells LLC, needs to be successful from the start. I mean, GM is betting this decade on it, basically, if you look at R&D spending. It's really important. And so the optics of it are questionable at this point, but maybe this is what GM needs to do.
So Bengt, to go back to your point of gasoline vehicle fires. Okay, it's the devil it's the devil you don't know that's the problem in this case. Most people don't know how electric vehicles work. They don't know that there's a difference between the battery in a vehicle and the battery in one of these things. They're consumer electronic products that people may have levels of familiarity with, and therein lies the problem. What I begin to wonder is, we know there are challenges in terms of people having, say, range anxiety, people wondering what happens when they run out of electricity, what happens when there's a power failure and their car is very low on state of charge. These are all challenges that the OEMs face in terms of convincing people to buy an electric vehicle. You don't have to convince anybody to buy a car, right? I mean, you don't have to convince anybody that they have some issue that they need to deal with an ICE car. This is a new technology. They need to convince them the new technology is safe, and is useful for them. The thing that I wonder about is, as you guys have pointed out with General Motors, talking about, to LG about like, oh, this is your problem. I mean, how do they convince people that these new Ultium batteries, which the Bolt doesn't have Ultium batteries, how they're going to be any good? And how does LG feel about their partner jumping on them like this?
Yeah. And also, to add to this toxic mix, GM for months has been telling us, oh, trust us. We've dived into this with LG, and the cells, the 2.1 cells that are coming from Holland, Michigan. It's a new generation of the cell. There are a few differences. It won't have this issue. Now there are reports based on the situation. It sounds like LG did what most suppliers who move their manufacturing from their parent company and their main country, they set up a factory in the US. They mimic that manufacturing method, and it turns out it sounds a lot like what the issue is with the Bolt EV cells is a manufacturing issue, not a materials issue. And so it turns out what GM may have been saying for months, that the cells at the Holland plant were unaffected. It sounds like maybe they were making the same mistake with those. And so there are on multiple levels some messaging blunders here, I think, that need to be addressed.
Well, look, GM came out and said there were two specific manufacturing defects that led to this. So that's why it's blaming LG. It was not a design issue. It was a manufacturing process defect. Hey, we just got a comment here from Marcus Miller, who said in 2018, there were over 200,000 ICE vehicle fires that killed over 560 people in the U.S. I haven't seen that documented anywhere, but it probably sounds true to me. But Bengt, what do you think? Are we going to have to give up on lithium ion and go to some other battery chemistry that is less prone to fires?
I don't think so. I mean, the mass market will shift to LFP cells just because they're more stable. They're easier to cool. There's so many aspects about LFP cells that make them just, in my opinion, especially as they've evolved in energy density, makes them a more natural choice for mass market vehicles.
And that's what LFP is, lithium iron phosphate. Is that right?
Yeah, that's right. And 10 years ago, they were just, it was looking like they were going to be way behind in energy density by weight, but they've caught up. They've had zero fires as far as I'm aware that weren't gross negligence. And they've really proven themselves in larger vehicles and in really sort of affordable taxi type vehicles. BYD is one of the main companies that's pioneered that. But then we've seen one supplier after another sign on to greater LFP production. We'll see other battery chemistries and types filtering in through the decade, but I think lithium ion is here to stay in these varying chemistries. And so this is an issue we have to solve. Better education of emergency responders, more idiot lights for the cars, perhaps, or better sensing of when is this car starting to go into thermal runaway. And based on a lot of these reports, these cars are starting to go into thermal runaway when they're hooked up to a charger or when they've just been charged and are parked. So automakers maybe need to address their safety systems a little bit differently and have those safety systems still be active when the cars are parked. This is something that internal combustion cars don't have to do. But if we had active safety system, if we had propulsion and battery monitoring systems active while the cars are parked, I think that could really make a difference. And then, of course, we're going to have to deal with, well, my battery charge is trickling away. Well, yeah, some of that charge is going to have to go toward monitoring. Mm-hmm. but I think it's, I think that this is a bump in the road, but it's a difficult one that we're going to have to get past.
So it's a large bump in the road. It is not not a sleeping policeman. It's more like a mountain, as it were.
Yeah.
So we heard this week that Ford is going great guns with its planning for the F-150 Lightning, with anticipated 15,000 vehicles built in 22, 55,000 in 23, 80,000 in 24, and 160,000 in 2025. I mean, is this going to have any effect on that product, or is that product there's just too much momentum behind it?
Well, I would say straight off, I think that Ford really lucked out in its partnership here. It was one of the last ones standing, and it had this wild bet with SK, which was in the middle of a very difficult situation in the U.S. and it almost was banned from doing business in the U.S. But if you check out how many fires have SK batteries had, Ford is in a good situation right now.
So what are you saying? SK has fewer battery fires?
Yeah, I don't think. I mean, this impression or data might need to be corrected, but I don't think SK has had any significant battery fires.
So this is,
why?
This is
you know why?
This is Samsung. So let's
What's
indicate.
that?
Well, the S is Samsung, right?
Oh, no. South Korea Innovation, I believe, is what it gets its name for. Samsung SDI is supplying the Rivian trucks.
Okay.
So Bengt, do you have any idea why SK's batteries don't seem to catch fire?
None whatsoever. It may just be an indication of their manufacturing controls. Mm-hmm. And let's hope that when they move manufacturing to Georgia and perhaps elsewhere, that they can maintain that, if it's really tightly guarded at this point. Those are the cells that are going to go into I believe that the Georgia made cells are the ones that are going to go into the F-150 Lightning. And, that's, but when I saw those figures, I was like, I mean, based on what Ford told us earlier this year about cell production at those plants ramping up gradually, it's just limited by cell production.
Hey, Ben, do you know anything about this design that Renault's talking about, and sort of an access panel to the interior of the battery, so that firemen can put out a battery fire far more quickly with a lot less water?
I don't know. I've heard about that, but I no clue how that would work.
Yeah, I don't know is that they've given out any details other than just say that they're working on this.
Mm-hmm.
All right, so Bengt, you actually broke some news this week about the Genesis GV60. Tell us what you discovered.
So the Genesis GV60, we learned through a tip late last week that it will be the first original equipment vehicle globally, perhaps not counting the Chinese market, but vehicle for global consumption that will have OEM wireless charging, and that wireless charging will come from Whitricity, company with a decent Detroit presence, and a company that has bought what was kind of the best known wireless inductive charging system until a couple of years ago, Qualcomm's Halo. And so it's likely that Halo technology would be the one that's actually installed in the Genesis. So far, Genesis, to us, they confirmed that it will get that system. but it's only going into a pilot program in South Korea for now.
Okay, so tell us what this is and why this matters.
Okay, so inductive wireless charging is important because so there are factions of the EV community. Some of them think of inductive wireless charging as a deal breaker, and some of them think of it as that's not really necessary. So on the pro side, inductive wireless charging can truly be a deal breaker because it offers this luxury experience when you're driving an electric vehicle. You never have to get out and pull out this heavy charging connector and cable and plug in the car in cold weather. And inductive wireless charging basically has two coils, a number of inches apart, and those coils transfer the current from one to another through a magnetic field. And so the receiver pad up on the car receives that current, and with the current standards, I think they could go up to 22 kilowatts, but this system in the Genesis is looking like 11 kilowatts.
But you have to put a mat down someplace that is plugged in, right?
Yeah.
So your car drives over the mat, and then
so you drive in your garage, and there's just a mat.
So it would be sold as a set in which you'd have to install to essentially lay out a mat and have the electrical part of it, installed or properly plugged into a 1450 outlet, a 240 volt outlet, and that mat would just and then you'd have an app or a module in the car's navigation system that would help you make sure that you're centered over that mat, and then it would be just kind of like what we lay our smartphones on all the time. It would charge the vehicle if we're looking at 11 kilowatts at a faster rate than most people can charge their vehicle in the garage with a connector. These mats and this technology could be incorporated into parking spaces. It could be, essentially. So let's get into the con part of this. The naysayers say, well, this hardware is just going to cost a tremendous amount to deploy. We're going to have to install these pads everywhere to actually make a difference. Hardwired chargers cost a small fraction of this amount, and it would be money far better spent to just increase the number of chargers. So it depends. I think this is a natural extension for a luxury brand like Genesis, and I would hope that other luxury brands do it too. I think it's cool, and it's going to bring down the cost for everyone else. So it's one of those kind of trickle down technologies that we're going to be seeing more and more of, and it's exciting to see one automaker start to take this step. And they wouldn't disclose to us whether or not they're going to be building that technology into the US versions too, but it's a possibility. And Hyundai has made decisions like this before with tech.
Yeah. Bengt, would it be likely that there would, does a vehicle that has this inductive charging capability, would it also still have a plug?
Yeah. Oh, yeah. You could still also plug the car in. The inductive charging would just be another way of doing it.
Mm-hmm. You had mentioned to me that you were somewhat surprised at results that when J.D. Power did its study of how people felt about electric charging capability. And I want to know why you were surprised. The only thing that surprised me was nothing, because basically it was people saying, we like free charging, we like charging that's convenient, and we like charging that is always available for us. And I'm like, yeah, and I like free snacks.
Well, what I found unexpected about the results, and I traded messages with them a little bit about this, was that in previous studies of public charging, some other organizations had really focused customer gripes on the interface and the charging experience, and that If they found a charger, they couldn't get it to work because there were too many steps, or they didn't do the steps in the right order, or they didn't use the right, they needed a fob that they didn't have, and they had to call the charging network, and that it was complicated to get charging started. What JD Power found that downtime in charging was a really significant factor and differentiator between networks, and I found that surprising. I thought that most of the charging networks were now staying on top of their network maintenance and making sure their chargers were fundamentally working. But no, if you go to the bottom of that list, there's some charging networks that aren't doing a good job at just keeping their chargers working.
Mm-hmm.
So that's an easy first step, guys. Just get more maintenance people and keep them running.
It's overhead.
Real good.
All right. So one more. So John, we've talked a lot on this show about fuel cells over the last many months. So Toyota announced yesterday that it will begin manufacturing hydrogen fuel cells at its plant in Kentucky, the Georgetown plant. And it's not for Toyota vehicles, it's for Class 8 trucks. What's going on here?
Yeah, I found that fascinating. So apparently it's going into the plant, or the part of the plant where they built the Avalon, and the Avalon's getting the axe. That's going away. And Toyota, once you're hired in, even as a line worker, they want you for life. I mean, Toyota is loath to fire anybody or lay them off. So if it's getting rid of the Avalon, how do you fill up the plant? And apparently they've settled on fuel cells. We know for a fact they've been working with Kenworth. At least all Toyota's development vehicles for truck fuel cells have been
Project Portal.
Yeah, have been with Kenworth's. Kenworth, it's part of PACCAR. They also make Peterbilt trucks. They're the last American-owned heavy truck company. Mack is owned by Volvo, used to be owned by Renault. Volvo bought Renault truck. Freightliner, of course, is Daimler. Navistar just got bought by Traton, which is part of Volkswagen. So PACCAR is the last one. They only operate in North America. How are they going to be able to afford the engineering to go into all this electrification? I would not be surprised if they're going to put their bet on fuel cells. And the fact that Toyota is building fuel cells for Class 8 semis, which it doesn't even make at all, is a fascinating development. I mean, Toyota's, to my knowledge, never been a supplier to other, vehicle makers in the industry with stuff like this.
Yeah.
What's your read, Bengt?
I tend to agree with what John said. I mean, this was a bit surprising to see Toyota jump into the role of supplier and essentially say that they're going to be building these to supply them. I was curious. Yeah, they must have a big contract with someone, or something's in the making. So,
Right.
We're going to see an announcement really soon. If they're moving production in 2023 to that plant for essentially a drop-in kit for semis and heavy-duty trucks, they've got business coming.
Yeah, somebody committed. This is not a build it and they will come kind of investment.
No. I mean, we've seen talk from Hyundai about something similar. GM has made that deal with Navistar for selling their modules to them, which I think are going to be built in Michigan. But we haven't seen anything like this yet. And Toyota has, I believe these are 2 fuel cell stacks of the same size as the Mirai incorporated into one module. I'm not sure of this, but I believe that's the case. And so these are and then with a battery pack too. These are going to be probably a lot like what those Project Portal trucks were, and
Mhm.
as proving mules, right?
Right. And now they'll just be completely productionized and Toyotaized, and I'm sure they'll be very cost effective. They'll have worked out the production engineering for it, so it'll no longer be like making jewelry. It'll just be like making Camrys. I mean, just
The other thing, the other little side story here that I think deserves some mention is that when automakers stepped up alongside President Biden, was that earlier this month? I
yeah.
believe it was earlier this month, and announced that they were going to target. Well, Biden said 50%, but automakers said 40%. Battery electric, fuel cell, and plug-in hybrid. 40% of those vehicles by 2030. Everyone wondered, no one really has volume plans for fuel cell vehicles right now. So maybe Toyota will find a way to get more fuel cells into production volume, because I imagine under the whatever the new system is in place toward 2030, it'll incentivize those vehicle types even more. So we'll see.
I just think this underlines that as we move forward, these new technologies are first going to appear in commercial vehicles before they're going to appear in consumer vehicles. I mean, so, we heard this week that Stellantis announced the electric Ram professional vehicle will come out in 2023. We've got the Ford e-Transits coming out later this year. We've got the GM Bright Drop electric vehicle, the EV600, is coming out this year. Now we're seeing, fuel cells. Hyundai is working on fuel cells for Class 8 trucks, Class 8 and Class 6 trucks. Now we have this Toyota announcement. I think that's where it's all going to happen. Even I think autonomous vehicles are going to happen in trucking before they happen in my driveway. I mean, it's just that's where the money is.
Yeah, and sustainability reports. Shareholders love seeing the green gloss in sustainability reports, and I think it drives up share price, and let's hope that stays, because then this trend of fleets actually helping the passenger vehicle market will continue.
Totally agree.
All right.
And with that, we probably got to wrap it up. You got one more?
This is just a fun one. Okay. So, so sticking with Toyota. So today they announced that they have sold 50 million Corollas. It's the best-selling car in the planet. Okay. That's just by far they've done that. And so, I got to looking at the best-selling cars. Okay, in the United States. And okay, John, you're really good at this stuff. What was the best-selling car in the United States in 1986? And it was not a Corolla, and it was not a Camry, and it was not an Accord.
Oh, you mean just for that year?
Just for that year.
That was the Ford Taurus, wasn't it? Or no?
No.
This was just in that 1 year?
Yeah, what was the best-selling car in 1986?
I mean, for such a stretch there, it was the Cutlass, right?
That was the Cutlass was 78 to 81, and in 83.
Okay.
So that's when the Cutlass was. And John, to your point, the Taurus was the best-selling car in the United States, 92 to 96.
Oh, yeah. Okay, so 86.
86. Let me tell you, I forgot this car existed. Okay.
Wow. Can you tease us with a brand here?
All right. Chevy.
Celebrity.
Wow. You got it.
A lot of fleet sales there.
All right, Mr. Smart Guy.
Sorry.
All right. So in 84 and 85, there was another Chevy that was the best-selling car.
You want to take a
Citation?
Cavalier?
Nope. Bingo.
Wow. Yeah.
But the Chevy Celebrity, I forgot that car
Forgot all
existed.
about it, right? Yeah.
Yeah, but
Wow.
all right. I
Hey,
think we've
Ben-
done enough.
Yeah, Ben, thanks so much for coming on. Love getting all your insights on all the green stuff. That's terrific.
This has been a lot of fun. Just talking shop and talking cars in general too. It's been
Good. Thank you for coming.
Well, good.
Thanks
We'll
for
have
having
you
me.
back again at some point too.
Okay, good.
Well,
Cheers.
good, Gary.
Let's do it next week.
Let's do it again next week.
All right.
Okay. And thanks to everybody for having tuned in.
Thank you. Bye-bye.
Autoline After Hours is brought to you by Bridgestone Tires, solutions for your journey, and by Magna.
Visit our website, Autoline.tv, where you can watch us live Thursday afternoons. Get your daily fix with Autoline Daily and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.